Hi, my name is Yuswin Sharif, and I'm one of the students in ECE102 Digital Circuit Logic class. I'm from Lab Section 1 on Monday 10 a.m. with Priscilla Vasquez as my graduate teaching assistant. So today I'm going to do a demo for my project 7, which is the binary coded decimal to 7-segment display. In this project, I'm going to design and implement a circuit to display an 8-bit binary integer using 7-segment displays and read-only memory, or ROM. So first, I created a table with Microsoft Excel for a total input of 8-bit binary numbers. Then, I assigned them as I7 to I0 using switches 0 to 7 on my FPGA board. I7 is assigned as switch 7, which means it's the most significant bit, or MSB, and I0 is assigned as switch 0, which means it's the least significant bit, or LSB. Then the output is displayed to the 3 7-segment display units from left to right. And the first 7-segment display unit is denoted by A2, B2, C2 all the way to G2. And the second 7-segment display unit is A1, B1, C1 all the way to G1. And so does the third 7-segment display unit is denoted by A0, B0, C0 all the way to G0 respectively. So right here we could see that the input has 8-bit binary integer, and also the output has the same 8-bit binary integer. Now, when we're dealing with 8-bit binary as the input and our output, we tend to take so much time to complete and increase, and we also increase the possibility of error when we're debugging. So it's really hard to see that an 8-bit integer as our input, especially if we have more than one input, and in this case we have 255 inputs since we're dealing with 8-bit binary integer. So to make it easier for us to see, what I did is I translated the input and the output from the binary form into a hexadecimal form. So the input and the output is still 8-bit binary integer, except I transform it instead of in a binary form. Instead of looking at a binary form, we're looking at the hexadecimal form, which is shorter, less digit, and it looks neater, and it's also work more efficiently when we use ROM. So after I translated my input and my output from binary form into hexadecimal form, I proceeded to create my ROM, which is the 256 by 24-bit ROM. And I also continued to create my circuit diagram. So the final product of my circuit diagram will contain the input, which is the 8-bit binary integer, also the 256 by 24-bit ROM, and also the output, which is also a 8-bit binary integer. And furthermore, in my circuit diagram, I also have this one thing called the clock, or the push button switch. So the push button switch here is used to show our output So I have to press it twice in each time I enter the input in order the output to be shown. So this is my FPGA board, and as you can see, when I reset them all to zeros and I double click the push switch button, it will show me the output. That's 0 right there. And now if I want to make it 1, I just have to turn it to 1 and then do the same thing. Double click the push button switch and it becomes 1. And this one is 2. And this one is 4. This one is 8. You cannot really see the 8, but that's 8, which is 2 to the third. And that's gonna be 16 to the fourth. 32 to the fifth. 64 to the sixth. 128 2 to the 7, and if I turn from 2 to the 0 all the way 2 to the 7, I should get 255, which is the correct value that we want. So that's all my demo for project 7. Thank you very much.